All right, lesson 12-6. This is in the classroom, one of my favorite lessons of the year. Remotely, quite honestly, I think this is going to be a little bit of a challenge. I really, really wish we could do this in the classroom, but not some. Well, we will do this in Zoom. But if you missed it in Zoom, you're definitely not going to have the same experience watching this video. Let's dive in. This is the homework, okay? Our notes today, we're taking notes on the homework. There are no separate notes. There is one new formula for one shape that you are familiar with. We'll get to that formula when we need it. But today's homework is mostly about applying the formulas that you've already learned and figuring out strategies for solving the problems. Let's look at number one. You're being asked to find the shaded area. That's the blue area here between the circle and the inscribed square. Inscribed is just a formal geometric word that means the corners of the square are on the edge of the circle. They're on the perimeter of the circle. Okay. One of the biggest problems that students have with problems like these is that they are in a hurry to start calculating. They look at this number 10 and they immediately pick up their calculator and start punching buttons. And when I tell them, no, stop punching buttons on your calculator, write down a strategy for what you want to do, then what they'll write down sometimes, even after we talk about it, you have practice on it, we talk about it some more in class, they'll just write down a bunch of calculations. What you want to train yourself to do for problems like these is to identify a strategy that does not involve necessarily numbers, or in particular, any of the numbers given for the problem. Like, what is our approach to finding this area? There's not a name for this blue shaded area, but how would you describe that blue shaded area, right? Or what strategy would you suggest to somebody to find the area without telling them what to calculate? Forget about calculations. Forget about the radius being 10. Okay, just generally, how would you find this area here? And if we were in the classroom, I would ask people for descriptions, suggestions, ideas, and get people to start talking. It really helps if you start verbalizing things, even if you're not so sure. Okay, can't ask you to do that over the video. So I just got to tell you, but it really would be better if you were forced to think about it and actually suggest a strategy. So the strategy here is that we want to find the whole area of the circle as if there was no square blank in it, right? Find that area of the entire circle. And then when we get that result, do what? What do you think? Wouldn't we subtract the area of the square from that circle area? And wouldn't the remainder then from that subtraction be the blue area in between? Okay, so I like to write the strategy like this in pictures: circle minus square. That's the strategy. Okay, for a lot of these problems, until you stop yourself from, rushing into calculations and numbers and identify the proper strategy, you have no hope of getting the right answer. If you rush headlong into just punching buttons and calculating things, and furthermore, if you just rush headlong into calculating things, oftentimes you come up with an answer that's just way wrong. And unless you've shown me what you're doing, I have no way of giving you any constructive feedback and saying, look, here's where you went wrong. It was with this part of the strategy right here from the beginning. Or, well, you just made this little careless arithmetic error. You plugged in the wrong value for in this place in the formula. So identify the strategy. We're not going to do any calculations today in these notes. We're going to identify strategies and make some connections also, okay? So the only piece of given information in this problem is that the circle's radius is 10. So what will really help is if you draw in the radius of the circle. Now, there are helpful places to draw the radius, and then there are unhelpful places to draw the radius. All radii come from the center of the circle. Where would be a good place to draw the radius? Again, I might ask for some ideas about that in class. I just got to tell you here, a good place to draw the radius would be right there to the corner of the square. Okay. Look, the radius of the circle is all you need to find the area of the circle. But how are you going to find the area of this square to subtract it from the circle? What do we need to know about the square to find its area? We need to know a side length, don't we? Okay, well, if that's 10, and if that radius is also 10, okay, then that right there would be an isosceles right triangle, a 45, 45, 90 right triangle. And you know stuff about 45, 45, 90 right triangles. Knowing that those two legs of the triangle are 10, you can find the length of that hypotenuse of that right triangle. That's what you're going to need to find the area of the square. Okay? So here's your strategy, and here's your connection between the given information and something you're going to need to find in order to get the area of the square, in order to complete your strategy. That's as far as we're going to go on this problem. The rest is up to you. Okay? Now, please take yourself away from that problem. Let's look at problem number 2. Or if you really want to think about that problem, if you want to finish it right now, pause the video, okay, and then resume. All right, what's the strategy for this problem? Okay. And look, I can't give you a sort of formulaic step-by-step 1, 2, 3, do this, do that, do the other thing, and you'll find a strategy. It really comes down to seeing things. And I don't know, honestly, of a good way to show you how to see things other than by trying lots of problems and looking for ways to describe shaded areas. Okay. So how I would describe this shaded area, if I were telling somebody how to find this shaded area, I would suggest find the area of that triangle. No, not the triangle, excuse me. Well, that was a bad, let me get my eraser there. Find the area of that part of the circle. Don't even find the whole circle area. Just find that section of the circle, or sector. Remember, this is the official word, the geometry word for a pie piece. It's called a sector. Find the area of that sector. We have a formula for that in the very last lesson. Okay. But if you find the area of that sector, you've got way too much area for the problem, right? You have to subtract some area. What are you going to subtract? You're going to subtract the area of that whole triangle, which is a right triangle. Okay. You're given the circle's radius is 8. Be good to put that there. Be good to put that there. Look at that. You've got all the information you need to fill into the formula for the area of the sector, and you've got all the information you need to fill in for the formula for the area of that triangle. Okay? But if you don't identify this strategy here, okay, then you don't have much hope of calculating the final answer. Please notice I've asked for final answers here in decimal form to the nearest tenth. That's how I want all the answers here. Okay. Decimal form to the nearest tenth. So plug in 3.14 for pi when you need to, or hit the pi key in your calculator. If you have a square root of 2 at like a 10 square root of 2 in your area, punch that in your calculator. 10 times the square root of 2. Okay. Let's go down and look at other areas. All right, number 3. Number 3 is a lot like number 2. Lot like number 2. Right? We don't need to find the whole circle area. We just need to find that sector, that 60-degree sector area. But of course, that would be too much. So then we're going to have to subtract the triangle from that sector, and then we'll get that little sliver of area remaining underneath that triangle. Now, because this is a 60-degree angle at the center of that circle, and the circle's radius is 12 there and 12 there, okay, this is not just any triangle. It's not a right triangle, but it is an equilateral triangle. I mean, for sure it's isosceles because we have two sides that are 12. But if it's isosceles, that means those two angles in the corners are equal to each other. And we've already got one 60-degree angle in the triangle. If you subtract that from 180, you've got 120 degrees left, split between the other two angles. It's got to be 60 each. It's an equilateral triangle. Okay. Now, I've got a formula for you for equilateral triangles. In a regular year in the classroom, we would have learned this formula in the 12.4 lesson that we skipped over, regular polygons. An equilateral triangle is a regular polygon because it's got all equal sides and all equal angles. And there's a special formula for the area of an equilateral triangle. And I'm just going to give it to you right here. You're going to use it for this problem. Equilateral triangle area equals, here's the formula, 1/4 s squared times radical 3. That s stands for a side length of the equilateral triangle. Okay. And since we've been given that the circle's radius is 12, that 12 doubles as a side length of the equilateral triangle, right? So here's your strategy, okay? It's a sector minus a triangle. That sector is a fraction of the circle, and that 60 degrees is your clue to the fraction, right? Number 4. A whole lot like number 2 and number 3, right? This, once again, is a fraction of the circle, but it's a much bigger fraction. Okay. You're being told here that angle AOB is 120 degrees. So there's your fractional part, 120 over 360. But if you find all of that area, of course, then you got to throw away or subtract some area. And the area you've got to subtract is this tall, skinny triangle. Now, let me give you a little help on this triangle. The angle given to you here is 120 degrees. That's that angle right there. Split this triangle into 2 right triangles like that. Okay? Because if you split that 120 degree angle in half, you get a 60 degree angle here and a 60 degree angle below. And so what you have is 2 30, 60, 90 triangles. Let me see if I can move my face out of the way here. 2 30, 60, 90s. You split that tall, skinny triangle into 2 congruent 30, 60, 90s. Okay. Now, what information have we been given in this problem? Well, the radius of the circle is 24. You're going to need that to find your sector area. Okay. But that 24, again, doubles as the hypotenuse of that 30, 60, 90. Let me outline that 30, 60, 90 right there. Okay. Now to find that 30, 60, 90s area, you're going to need both of the other two sides of that purple triangle. You're going to need that short leg, that would be your base, and you're going to need that longer leg, that would be your height. Okay. And then you got to use 1/2 times base times height to find that. So you got some 30, 60, 90 work to do there. Then you got to find the area of that 30, 60, 90 triangle. Then you got to double that because there's two of those little 30, 60, 90 triangles. And then you got to subtract that from your sector area. Okay. And again, all answers, I'm asking for the nearest tenth. So don't hesitate to turn square root numbers and pies into decimal values as soon as you want. Okay. If you don't like doing your algebra or your arithmetic with square roots and pies, just turn them into decimals as soon as you want. Okay. Number 5. All right, here's a different picture. Finally, it's not going to be a sector minus a triangle. So what's this one going to be? What's your strategy for finding this one? Have you noticed that all of the strategies so far have been subtraction strategies? You remember a couple of sections ago with the rectangles, with the L-shaped rectangles, how I drew your attention to the fact that you could divide them into pieces and add the little pieces together, but pay attention to the possibility of subtracting one piece from another. And all of these problems so far, we've needed a subtraction strategy. How about for number 5? Do you want to use a subtraction strategy for this one too? Or do you want to divide that area into little pieces, find all of the little areas and add them all together? Well, I think the most straightforward strategy for this one is, again, a subtraction strategy. Let's start by finding the area of that large square, that entire square, right? And then what do we have to subtract from that? We got to subtract 4 congruent pieces, right? And each one of those pieces is a sector of a circle, right? And each one of those, this is a right angle up here in the corner of the square and a right angle in every other corner, right? So we got 4 little sectors. I got a question for you. What fraction of a circle is that sector? Since this is a 90-degree angle right there, what is that? Is that half a circle? A third of a circle? What is it? You recognize it. You recognize the fraction of the circle that sector is right up here in this corner, don't you? It's 1/4 of a circle, right? So we've got a square minus 4 whats? 4 quarter circles, right? Okay, well now let's multiply the 4 times the 1/4. And what do we get? We get a square minus, what is 4 times 1/4? It's 1, isn't it? So in effect, our strategy becomes simplified to a square minus a circle. Now, you probably didn't see it that way when you first looked at this picture. But now that we've written that down, doesn't it kind of make sense? Right? And wouldn't doing this calculation, square minus circle, be a little bit easier than finding the area of this sector and then multiplying it by 4? Once we start actually using numbers, this is going to be a little bit easier, won't it? Okay. Now, what information were we given? That the side of the square is 10. So this whole thing is 10. And this whole thing is 10. So that part of the strategy is going to be easy to do, the area of the square. For the circle, what do we need to find the area of the circle? What piece of information do we need? We need the radius, don't we? Okay, so what is the radius of this circle going to be? And you see that how the circle could be formed by putting these four sectors, just like cutting them out and piecing them all together, right? So they make a circle. What would the radius of the circle be? I'm not going to say. I think you know. Okay, finish the problem, check the work and the answers that I've posted. Okay, number 6. Going to need a subtraction strategy again. This one is going to start with the big equilateral triangle. You're told it is an equilateral triangle. And once again, we have a formula for an equilateral triangle. I'll write it again here. Okay, it's 1/4 s squared times the square root of 3. S being the length of the side. You are told the length of the side. It's 18. So that's going to make calculating the big triangle area easy. Okay. And then turn it into a decimal. Right? But what are we going to have to subtract from that triangle? Well, again, these are sectors going all around, right? And there's 3 of them. They're all congruent. So we're going to subtract 3 sectors. And you've got a formula for a sector. But hey, how many degrees is in one of those sectors? Now let's focus on one of them. This one right here. This is an equilateral triangle here, right? What's the angle in that equilateral triangle? You know, it's 60 degrees, right? So we have 3 60-degree sectors. Again, imagine cutting those sectors out of this triangle and putting them all together, 60-degree angle next to a 60-degree angle next to a 60-degree angle. How many degrees is that? It's 180 degrees, right? So what fraction of a circle do we have if we put all 3 of these sectors together? I'll give you a hint. It's not a whole circle, right? This is a whole circle in number 5 because we put 4 90-degree sectors side by side. 4 times 90 is 360 degrees. We got the whole circle. Here we're putting 3 60-degree sectors together. That's only 180 degrees worth of a circle. What fraction of a circle is that? It's a half, right? So we could simplify this strategy to saying, let's find the area of the triangle and then subtract the area of 1/2 of a circle. Okay. Now to find that circle, again, you'll need its radius. Okay. What is the radius of that circle going to be? Again, if you put these 3 sectors together side by side, what's the radius of that half circle going to be? I'm not going to tell you. Again, I think you can figure it out from the picture. It's not difficult. Okay. Try it. Check the answers. You know what? Check number 5. Check your answer to number 5 before you even try number 6. Because if you get the radius of this circle wrong, you're likely to get the radius of this circle wrong also. Okay. But if you get this one wrong and you look up the answers and you go, oh, okay, I see then you'll probably get number 6 right. Okay. Number 7, I want you to skip because it involves a regular hexagon. And I don't want to bother trying to help you figure out how to find the area of a regular hexagon, although it's not that big of a deal, but I'm just going to skip it. If you want to try it and, I don't know, just impress me by turning in your work for this. But, well, I posted that you're going to see the answers anyway. Never mind. Don't even bother. Number 7. Number 8, last problem of this kind. There's 4 more problems in the assignment, but no more like these. What would your strategy be here? Is it still a subtraction strategy, or do we want to add together a bunch of little areas? Still a subtraction strategy. Okay. We're going to find the area of the square. And then what do we have to subtract from that square? Well, we've got 4 circles this time, right? And this is really 4 circles. You can't like cut these circles up rearrange them, piece them together, and make one big circle out of it. It doesn't work that way. Okay, 4 circles. So calculate the area of the square, calculate the area of one of those little circles, multiply it by 4 before you do the subtracting. Okay, now what have we been given? We've been given a side of the square, which is 40. Okay, that's 40. Now let me give you this one more tip. I'm giving you a lot of help getting started on these problems here. Okay, but on the quiz and on the test, you've got to identify the strategy yourself. You got to use the right formulas, make the connections here. When I say make the connection, what I'm saying is figure out what the radius is. How do you connect this side length of 40 from the square to what the radius of one of these circles is? Well, I'll give you a little help with this. Here's the radius of the circle, right? So how's that going to compare to the 40? Right? See, this number 8 going from the side length to the radius is a little bit different from numbers 5 and 6. All right, so just be careful about that one. All right. And then finally, in this assignment, there are 4 more problems asking you to convert some measurements from one type of square unit to a different type of square unit. I just think you could use some practice with these, okay? So that's it. That's the notes for today. Good luck on the homework, and there is one more video lesson before the quiz. So we'll see you next time. Bye.